guys, is this. We're going to start looking at derivatives of trig functions. Now, if you recall, guys, what were the 6 basic trig functions? Sine. Okay, so sine, cosine, and tangent. Come on.
I've never even seen these letters together.
All right, so you said they were sine, cosine, tangent, right? Secant, cosecant, and cotangent, right? Now we said, guys, typically we work best if we can kind of get stuff broken down into what 2 of the 6. Which 2 of those 6 functions we typically work best with? Sine and cosine. So I'm going to tell you this right now. Sine and cosine are going to be kind of integral for us. So we need to understand some things about tangent, secant, cosecant, cotangent. So do you guys agree by rule that tangent is equal to, anybody recall what that was equal to in terms of sine or cosine and or cosine, I should say? Right? I went to the beach and got my sine over cosine on.
Oh, we got your 10. Oh, okay.
You like that one? So if tangent is sine over cosine, what's cotangent, kids? Reciprocal, cosine over sine, right? So I want to remember these. You guys recall what cosecant was, the reciprocal of? 1 over sine, right? So what's that make secant, kids? 1 over cosine, right? Okay, so we're going to talk about some derivative formulas right here today, some of which we're going to just write in there, and then some we'll use some quotient rules in terms of helping us come up with a rule for it. But guys, the question that we're asking today is this: how do you find the derivative of a function involving trig functions? And in order to answer that, we've got to be able to compute the derivatives of the 6 trig functions. The way I'm going to present the trig functions are going to be a little different than what you might see in your answer book, but I think it's going to be beneficial for you. Second thing we're going to look at doing is finding derivatives of trig functions using prior rules, so don't forget about what we've learned. Okay? And then we're going to look at the derivative of a trig function in a real life situation. So I don't know if we'll get to that real life situation today, but we sure will try. So let's get rolling right here, guys. The objective here of derivatives of 6 trig functions, I could look at decimals and show you this real quickly. I'm just going to kind of show you sine and cosine. But guys, I'm going to start the first one out right here. We're going to go the derivative of the sine with respect to x of some sine function of u. Okay? I'm just going to tell you what the derivative is. You might want to write this down. The derivative of the sine, anybody know it? It's actually u prime times the cosine of u. So it's an inside function u, the derivative of that times the cosine of u. All right? And the next one I'm going to tell you right here is this. The derivative of the cosine is u prime times the negative sine of u. Okay? So I just kind of want to talk about that one up there. What does it say the derivative of the sine is? Okay. I'm going to go in here and simply talk about the sine of x. So guys, if I look at this right here in decimals, okay, there's the sine of x. You guys agree with that? Okay, I'm going to kind of just look at one interval here real quickly. So I'm going to zoom in a little bit. Kind of look at maybe one cycle of the sine function here. So let's see what I can come up with. Now remember, everything that we're talking about is measured how now? Not in degrees, but in. Okay, does that look about like one sine? What does that look like about one cycle or one period of the the sine function? Okay, guys, clear over here on the left right here. What's the derivative appear to be right here? Positive, negative, or zero? Okay, it starts at 0, but is the slope positive, negative, or 0? Okay, where's my first slope 0 at? So isn't there going to be a 0 kind of down here? Okay, and then I've got negative slopes, so between this point and this point, my graph should go negative until it comes back to what again here, guys? Okay, I'm going to type this in here. We said the derivative of the sine of x would just be the cosine of x. Let's just talk about this right here. Guys, this point right up here, does it look like this slope from here to here might be about positive 1 in that box? So they graph a 1 right here. Now right up here, guys, I click on this. Doesn't that kind of correspond to this point right down here? Isn't the slope 0 up here? Which corresponds to that right down there of 0. Then my slope from here to here, my slope goes negative everywhere, doesn't it? Until it wraps back down to what slope again? Okay, so this goes negative slope, but eventually it wraps back down to a 0 slope, right? So it looks like to me the derivative of the sine is simply what? Cosine. And if you had to look at this right here, that's what you would see. Okay? Cosine is the derivative of sine. All right? Now, I told you the other one, the derivative of cosine is negative sine. Think about this. Doesn't this have 0 slope right here? The blue line. Think of the blue line as the original function. Isn't there 0 slope here? Does that match here? Okay, but now guys, right here, what kind of slope do I have from this point to this point? Increasing. They actually have a negative values graph down here, don't they, guys? So the derivative of cosine of x is actually, what do we say? Negative sine of x. Okay, so the blue graph right here, if I was picking on this point to this point right here, don't I have a 0 slope right there and right there? And then my slope of the blue line, slope is negative, so that's why this is graphing negative values till it comes back to 0. Okay? So here's the deal, kids. What's the slope, or I'm sorry, what's the derivative of sine? Cosine. What's the derivative of cosine? And if you know those two things, we can compute the derivatives of the rest. Okay? So let's find the derivative of tangent. You don't need to write this down just yet. Just help me out with this, okay? So with the derivative of tangent that we're going to get here, guys, you told me that the tangent function can be written as sine of x over cosine of x, right? Well, couldn't this be like a quotient rule type thing here? So to get the derivative of tangent, which is sine over cosine, I'm going to let u equal the sine of x. I'm going to let v equal the cosine of x. So what's that make u prime, kids? Cosine of x. What's that make v prime? Negative sine x. Okay, here we go. By rule, we're going to have u prime times v, so those two, right? So we're going to have u prime times v, which is cosine squared of x, minus uv prime, which is negative sine squared x. What's that negative and negative going to turn into, kids? And then this will be over v squared, right, which will be cosine squared of x. Now, kids, biggest identity in trig. The biggest identity in trig. If you have a cosine squared of one value plus the sine squared of the same exact value, what is it? It equals 1, okay? If you remember back here, cosine squared plus sine squared is always going to equal 1. That's just a unit circle identity. So our derivative becomes 1 over cosine squared of x. Now, kids, 1 over cosine could be called secant, couldn't it? And you might write it as secant squared, but I think for our purposes when we're doing stuff, you guys already told me you work better when you see sine and cosine as opposed to the other 4 functions. Is that true? Okay, Hunter?
Why don't the two cosines cancel?
They would cancel if we were multiplying this times this. But since there's an addition between the two, can't do that. Okay, this would really become 1 minus the tangent squared of x, which would be the same as the secant squared of x, which is also the same as 1 over cosine squared x. And I think for our purposes, working on this, I think we're gonna be better off if we leave stuff in terms of sine and cosine, okay? So we're gonna call the derivative of the tangent of u, kids. Whoops, didn't wanna do that. Wanted to do this. We're gonna, whoa. See that in outer space.
It's like on my grandma's phone.
Yeah. She must have a really big phone. She carries something like that. Her pockets must be big. Okay, this is gonna be the same as u prime divided by the cosine squared of u. Alright, that's the derivative you're gonna use for the tangent of x. Okay? Now, I can go through the rest of them and show you how I get those derivatives using quotient rules, or you can trust me to leave them in terms of sine and cosine. What would you like to do?
The ladder.
The latter. Okay. Oh boy, what did I do? There's my little sheet. Okay, so the ones that we probably aren't gonna see a lot of today, but I'll get them down there for you in terms of sine and cosine. The derivative of your cosecant, my friends, the derivative of your cosecant is gonna be the cosine of u. I should write it this way, kids. I'm gonna write it as okay, we're gonna write this as u prime times we're gonna write it times negative cosine of u over okay, make sure you've got that down the way I have it. U prime times the negative cosine of u over sine squared of u. Right? Now again, do I think I'm gonna, do you think you're gonna see a ton of cosecants? Not really, okay? Your secant one, my friends, your secant one, I'm gonna make sure I've got the right one. This is gonna be u prime times the sine of u all over cosine squared of u. Okay, those are going to be your two difficult ones right there. And then your tangent one, my friends, your tangent is going to be u prime over negative sine squared of u. All right, now again, just because we have new rules, does that mean we throw everything we've learned prior to this away? Or do we probably have to use it with this somehow? We're gonna have to use that with this, okay? So you might wanna have access to those rules, so let's go ahead and try a few right here and see if we can come up with.
Alright, so please go back.
I'm sorry. Which one?
That one.
Okay, yeah, let me know when you're done, I'm sorry, I was going too quickly there. My mistake.
What's the grade? Why did you casually make your first mistake?
All right, are we good there now, kiddos? All right, let's go to the second page here, see if we can't figure some of these things out here. All right, so on page 2 here, do I have the right page here, guys? Okay, the examples say find dy dx of the following. Guys, when I say find dy dx, it's just simply saying find the derivative of y with respect to x. So in this first one right here, let's not think too hard. You have y prime. You got some constant 3 out here, so that's just going to stay out there. So the part that I'm really looking to differentiate is the sine of x. And what's the derivative of sine of x?
Negative? No, cosine.
Cosine of x. So it would really be 3 times the derivative of sine of x, which would be 3 cosine of x. Do I have to do anything really with u prime in this at all? No, because the derivative of x would be what value? Okay, so there is your derivative right there, 3 cosine of x. Okay. I like the next one. What's it say the derivative of tangent was?
1 over cosine squared.
1 over cosine squared, or we wrote it in terms of u prime over cosine squared, didn't we?
Yeah.
Okay. So our u value though, again guys, is just what?
X.
So this is going to equal 1 over cosine squared of x. Don't get caught on the last part.
Plus 2.
Plus 2x. Yeah, the derivative of x squared, we're back to a power rule with this one, so plus 2x. Okay? You guys try part C on your own, see what you get there, okay? Nothing with the chain rule in there yet, alright? So just pretty straightforward derivatives involving your new trig functions, maybe mixed in with some power functions. We'll get some water quickly. You guys have an answer when I get back, alright?
Oh, nice thing said he wants us to do it for the solo edition.
Alright, anybody have it here?
He's like, I saw you standing there. And I was like, we should do it when we okay.
Okay, now when you say 5 times the negative sine of x, is it okay if I take that negative and move it out in front of the 5 there? So I've got negative 5 sine of x. Okay, negative 5 sine of x plus, what you guys come up with?
1 over
1 over 2. Yeah, this part right here, this is a reminder, this is x to the half power, isn't it, kids? So the 1/2 go out front, 1/2 x minus half power by power rule. If I don't want that exponent to be negative, we move it to the bottom. It would become x to the positive 1/2 in the bottom with 2. But x to the 1/2 is root x. So you should have, in the end, negative 5 sine x plus 1 over 2 root x. Okay. All right, this is where things get kind of fun. I think. Maybe I'm wrong. Okay. This time, guys, right in here, do you have just an x in there or something a little different? Okay, so that pi x is kind of like our function u right there. Okay, so if you look at the derivative rule for sine of x, isn't your derivative rule u prime times the cosine of u? Okay, well what would u prime be in this situation here, guys?
What?
Yeah.
Just be pi, wouldn't it? Times, what's the derivative of sine?
Cosine.
Be pi times cosine pi x. There it is. Okay.
We also see P.
What are you allowing u to be in this next one? What's the u value in that one? Okay, so let's think about this. We got to differentiate x to the third first, which is what? 3x squared. That's your u prime. This is kind of like negative 1 cosine of x, isn't it? So that'll be like times a negative 1 there. And then what's the derivative of cosine, kids? Negative sine of your u value, x to the third. But guys, right here, a negative times a negative, what's that gonna yield? So what you're really gonna end up with here in the following is y prime equals 3x squared times the sine of x to the third there. That's what you'll end with right there. Hey, you guys try F on your own, see what you get. Think about this. What I tell you cosecant was again, guys, in your rules?
Prime times negative cosine u over sine squared.
I think I messed that up. I might have messed that up. Hang on a second. Let's see. Cosecant's the same as 1 over sine, right?
Yeah.
So if I let u equal 1, u prime would be 0, right? And if I let v equal sine, cosine, right? U prime v would be 0. No, I've got it right. I've got it right. Okay. So what did we say the derivative was? U prime times negative cosine, is that right? Okay, what would u prime be in this situation? 2. So we're going to have 2 times, whoops. Two times, what do we say, negative cosine of 2x all over sine squared 2x, is that right? Okay, now I'm probably going to rewrite that top. I may not leave it like that. I might do what here?
-2
Call it negative 2 times
cosine.
okay. You guys good with that? Here's the thing, kids. There's like a cosine of 2x over 1 sine of 2x. Things, I just think it's best for us to leave things in terms of sine and cosine.
Yeah.
Because something might have a cosecant and a cotangent. I would rather deal with 2 trig functions in the end to try and solve problems when we start doing optimization as opposed to 6. Are you okay with that? Okay, so I like to try and keep things in terms of sine and cosine. All right, my friends, let's try some more rules here. Let's see what we can come up with. These next ones right here. Got to think about what's going on here. Did you guys have everything right there? So far, so good? All right, my friends. Next one, more examples. Find the derivative of y with respect to x. The next one says y equals x times the secant of x. So there's some trig rules involved here. Last 3 examples had some chain rule applications with those trig functions. What else is coming along with this trig function now, kids? Times by x. So this is kind of one of the ones where this would have to say, ooh, this is a product of functions with relative to x. So I'm going to let u equal what, kids? Yep. And I'm going to let v equal the secant of x. Okay. All right, so talk to me, kids. What's u prime here for part A? 1. And then by our new rules, what's the derivative of the secant of x?
U prime. So,
Cosine of x.
1
like it. All agreed there? Okay, let's roll on this. Here we go. Our derivative of this would be u prime times v. So these two times each other first. So 1 times what? So f prime of x is going to equal 1 times the secant of x to start with. You all agree? Minus uv prime, which would be x times the sine of x over the cosine squared of x. Holy moly, this is going to get nasty. And then this is all going to be over v prime, isn't it, kids? I'm sorry, not v prime, but v squared. V squared, right? Which would be what? Secant squared of x. Oh my. And this is our solution right in here.
Why is it minus?
Quotient rule, uv prime or u prime v minus uv prime up top over v squared.
Would it be plus since it's product? Yeah.
Oh, why do we do quotient rule?
I never get to it.
That's a good question. You said it was
I had my mind set on quotient rule. Okay, well, let's fix it then. We would have been right here. This should have been a what here, guys? Plus. There it is. Good catch, guys. Been a long day.
Today's kind
That better?
Yep.
All right. Let's talk about B then. Tangent of e to the x. Okay, this is just like one function, but this is like the tangent of u. The derivative for the tangent of u, take a look at your front page again. Isn't that like u prime over cosine squared? Well, what's u prime, kids? So I would say y prime equals u prime up top, e to the x, over cosine squared of your u value, which again would be. Okay. You guys try the next one on your own, part C. Make sure I'm good. This would be a product rule mixed in with chain rule, isn't it? This one gets kind of messy. Someone like the wrestling sweatshirts, these are cool. Thank you. Simple is nice, I think. What do you guys want to let u equal here?
3x.
So real quickly, u prime would be what here? So that means b has to be the cotangent of x squared. Put b prime down here. I don't know the rule, you're gonna have to help me.
2x over minus sine squared x.
So again, if I go back and look at rule for tangent here on page 1, or it's cotangent, right? So it's u prime over
Minus sine.
negative sine squared of u, okay. So it would be 2x over negative sine squared of, oops, x squared, right? There we go. You all agree with my u's and v's and u primes and v primes there? So we're going product rule, right? Okay, here we go. I'll try and squeeze it in here as best I can. U prime times E, what have you got, guys?
3 cotangent.
So 3 cotangent x squared, is that right? All right. How about UV prime? Could I take the 3x times the 2x with these two?
Yeah.
Could I call it 6x squared up top? Is that okay?
Yeah.
Okay, so this is going to be plus, or if I want to, what can I do with this minus sign, guys? I can kind of like move it out front because this is like a negative value anyway. So this is like a negative 2x over sine squared of x. So I'm going to call this minus 6x squared. Does everybody understand where the 6x squared just came from for uv prime? That's the 2x and 3x together, right? All over sine squared of what? All agreed with that? Okay. Guys, what I'd really like to do is finish up example 2 today. We'll probably look at the last one tomorrow. Show a quick quiz and time to work. Do I have those last 3 right? Think we're good with them? Think so? Sound good? I like them. Okay. Let's look at the last one today, kids. This here says, hey, we want to find the value of a derivative of cosine 3x plus 3 when x is what value? 4. Okay, so really what we're saying is this, guys. We're saying we have a function, f of x. And that f of x is equal to the cosine of 3x plus 3. The question really is saying, what is f prime of 4? We want to know what the derivative is when x is equal to what value? 4. Well, I can't evaluate that until we know f prime of x. So let's do that. F prime of x, my friends, is the following. Okay, so the derivative, what would u prime be in here?
-3.
There'll be 3 in there, right? But then the derivative of my cosine is, so that's where the negative comes in. It'll be negative 3 sine of 3x plus 3. You guys all agree with that?
Yep.
Well, here's the deal now. And you gotta be very careful on this. Now, when we're dealing rates of changes with trig functions, we're looking at f prime of 4. Make sure your calculator is in what mode? Radians, all right? So kids, what are we going to plug in for x right here now to find that? Okay, so this f prime of 4 becomes negative 3 sine of 3 times 4 plus 3. Now guys, my Norfolk Highway 3 math skills aren't very good. What's inside this set of parentheses after sine? Did I hear 15? Okay, so in your calculator, what I'd like you guys to do is to find the sine of 15, understanding that if it's not 15 degrees, that's 15 radians. Okay, by the way, how many radians in a unit circle? How many radians are in there? 2 pi radians, right? 6.28, all right? Guys, we're going to take the sine of 15 radians and then multiply that by what coefficient out front?
-3.
Okay, what are you guys getting when you do that?
-1.95.
Is it negative 1.95 about?
Yep.
Okay, so the slope there is about negative 1.95 here. I'm going to do something here, kids. I'm going to show you this right here. Decimals is pretty cool. Let's see if that's right. I'm going to wait till everybody has that down. You guys on board? Let's jump into decimals and just kind of dissect this, what we just did. So our function, what was it again, kids? Cosine of, I'm going to write it in there this way. F of x equals cosine of, what was it, 3x plus 3? That sound right? And then I'm going to try to type in f prime of, I don't know if this will even do it. Type in f prime of 4 there. Okay, what's it tell me f prime of 4 is? Negative 1.95. Okay, and if I was looking at this at the term x equals 4, kids, on my function, take a look right here. At that point where 4 is, does that look like about, well, hey, look at this. From this point up here down to this point, that slope's pretty steep, isn't it, with that line like this? Is almost a tangent right here, isn't it? If I go from this box down to that corner of the box, that slope would be negative 2, wouldn't it? So we've got to be pretty darn close. So negative 1.95, algebraically, you understand how we got that? And then graphically, can you confirm this here? Well, absolutely. All right, I don't think we've